Sa araw-araw, tanging ikaw ang palagi kong hinahangad. Laging tanaw sa'yo ang ilaw na nagsisilbi kong liwanag. Lapis ang ngiti kapag ika'y kaharap. Ramdam ko ang pagmamahal, giliw. Namumukot ang ikat, walang katulad. Ikaw lang ang para sa'kin. Sa'yo lang ako.
Okay, so our next speaker is Madalag Elementary School First Honors, Madalag National High School's valedictorian, Bachelor of Science in Nursing at West Visayas State University cum laude, MAED major in Physical Science at Aklan State University, doctorate degree in Science Education major in Biology candidate at West Visayas State University. A National Research Council of the Philippines, Associate Member, Division 1, Educational and Government Policy, State University and Colleges Teacher, Educators Association, Lifetime Member, Philippine Association of Institutions for Research Incorporated, Associate Member, Renowned Nurses Association of the Philippines, Member of WVSU Alumni Association, recognized by Google Scholar as a research author, research advisor, awardee in division and region science investigatory project. Development of chalk from selected herbs as cockroach, Periplenanum americana, repellents, best researcher paper. University Symposium on Research and Development highlights Aklan State University Best Researcher Paper, and an International Conference on Agricultural Research, Philippine Association of Institutions, Research Incorporated. Best Researcher Presenter, Second International Conference on Agricultural Research, 2018, Philippine Association of Institutions for Research Incorporated. Localized Experimental Learning Infused Resource Package and Earth and Life Science Best Research Paper. First Asian Virtual Multidisciplinary Research Conference 2020. Philippine Association of Institutions for Research Incorporated Best Research Presenter. First Asian Virtual 2021 CTE Research Conference 2021, Aklan State University, Operation Galugad. ELT infused localized module as means of enriched experimental learning, best research presenter, Asian Virtual Multilateral Research Conference 2020. Ladies and gentlemen, let's welcome Mr. Rafael Kevin I. Nagal.
All right, thank you so much, sir, for that very nice introduction, and good morning once again to our esteemed participants as well as my co-guest speakers or resource speakers for today. Okay. So I will be presenting my topic for today. So just give me a few seconds. Actually, I'm so happy that the previous presenters or the previous discussants were able to present topics regarding variables and statistical tools. So my job for today would be an easier ones. So yours truly will be presenting identifying the right statistical tool in conducting your quantitative research. So yours truly, Rafael Kevin Nagal, RN, LPT, MAED, from a head teacher of Kalibo Integrated Special Education Center in the Division of Aklan, Department of Education, Philippines. Okay, so before I begin, let's have a recap of what statistics is. So, as mentioned by our previous discussants, statistics is that branch of science which deals with the collection, presentation, and analysis as well as interpretation of data. There are two forms of statistics that we are using when it comes to research. So, they can either be descriptives such as your mean, mode, median, frequency, and standard deviation. We also have inferential statistics, such as Pearson's R, Spearman-Rho, ANOVA, and t-test. Well, both of them are usually used if you're going to have inferential statistics, because we're going to know the differences between the mean and the median of each when we are doing the inferential statistics. So I know that based on the names alone, we can easily understand what's the differences between descriptive and inferential statistics, right? May I know if you agree with me that when we say descriptives, we are going to describe a certain thing, a certain variable. And when we say inferential, we're going to predict, we're going to find the differences or the statistical differences or statistical relationships between those two. So let's have like a practice or a recap of how much we know about them. I have some situations here, and
Hindi
hopefully,
na bagas, isag ako.
we will be able to understand the differences between the two. I think some
Unsa?
Sir Jen, I think the your audio is open too. So okay, thank you, sir. Okay, so I would like to ask anybody to please identify whether the following situations are descriptives or inferential. So number one and is a teacher computes the average grade of her students and then determines the top 10 students. So you may actually use the chat box to answer whether it's descriptive or inferential. Or you may open your microphone so that you can be acknowledged. So for number one, a teacher computes the average grade of her students and then determines the top 10 students. Is it descriptive or is it inferential statistics? Okay, Sir Ricky has answered it's descriptive. Sir Arnell as well. Okay, very nice. The answer is, of course, that's descriptive because we're going to use mean here. Okay. Number two, a medical researcher predicts the number of affected COVID-19 patients after 6 months. Great. Sir Ricky is so fast in answering. Thank you so much, Sir Ricky. And that is, of course, inferential because we're going to use like a linear regression for this. How about this? Number three. A researcher studies the effectiveness of a new fertilizer to increasing food production. So we're talking about effectiveness. So for number three, is it inferential or descriptive? Yes, Ma'am Vanessa got it correctly, and that is inferential. And number four, a janitor counts the number of various furniture inside the school. Wow, this is so amazing. Everybody knows the differences perfectly well. So when I say this one for number four, it's more of like frequency, right? Okay, we're going to count those. So that's very clear. So this is usually associated with quantitative research when you say statistics. Now let's define variable, and this is like a sort of a review of the previous discussant's discussion. Now, a variable is a characteristic or attribute of a person or an object which can assume different values or labels for different persons or objects under consideration. So, it's very simple to understand that when you say variable, it's like this. I'm thinking of something to wear for the conference. So, let's take, for example, a woman who is going to attend a conference would think of a dress. So, I want a dress. But specifically, there are a lot of variation of a certain dress. So it could be green or pink. So these are your variables. Now, in some instances, there are only two variants. Like it can either be true or false, or it can actually be like only two, like male or female. However, in some instances, variables can actually be more than that. So let's take, for example, when we are going to court a girl, right? So courting a girl entails a lot of things. Like, for example, there are only two choices. It's either a yes or a no from a girl when we ask them questions. Do you love me? Will you marry me? Yes or no. However, for some girls, we actually know that they don't answer directly. So it's not really limited to yes or a no. But we need to define what's a no and what's a yes. Like, for example, they would say, I'm not yet ready. My parents are so strict. And of course, studies first. That is if the person asking them would look like this one. However, it's very clear that if a person would be looking like this or have values of this one, would actually answer this, right? And so, of course, variables are such like that. Now, let's have a clear definition or distinction. The great divide between independent and dependent variables. Of course, there are other variables that we have has been discussed. So when you say independent, it's the cause. The dependent is the effect, like the input and the output. It's so on and so forth. Now take note that the independent variables are the ones that we manipulate, the ones that can stand alone from the term itself, independent. While dependent, on the other hand, these are the variables that cannot stand alone and are not manipulated. So for example, in the following studies, now take note, like a hint now, but not all the time. It applies to many, but not to all. Variables are usually found in the title. So I would like to ask somebody to please tell me which one in each of these titles are the independent and the dependent variables. So, the first one, the relationship between exposure to mass media and smoking habits among female students. So, can somebody answer this one? Okay. So, well, the second one is effect of peer counseling on student study habits. And number three is knowledge of the dangers of smoking, attitudes towards life, and smoking habits of young professionals. So, let's have an answer for them. Highlighted in green are the independent variables, while the dependent variables are highlighted in blue. Let's take a look. So, for example, the relationship between exposure to mass media and smoking habits, our independent is the exposure to mass media, and the smoking habits would be the dependent variables. Like another one, peer counseling will be the independent variable. The dependent will be the student study habits. If you could have noticed, right, the cause will be the independent, the dependent will be the effect. Okay? Next, knowledge and the dangers of smoking and attitudes towards life versus the smoking habits of young professionals. So we can actually see that there are two independent variables and just one dependent variable. Okay? Now let's actually take a look at the measurement. So measurement is the process of determining the value or label of a particular variable for a particular experimental unit. So they can either be classified as either discrete or continuous. Okay? So let's define each of them. You can actually use your chat boxes to answer. So number one, please identify whether this is discrete or continuous. The number of positive COVID patients in the hospital. So when I say discrete, the measurement is usually fixed. We can easily determine. On the other hand, when I say continuous, it varies. Or it's like it depends, right? So it's like infinite. Well, discrete is finite. So for number one, can somebody answer? The number of positive COVID. Of course, Sir Arnell has got it correctly. It's discrete. So it's really fixed. Next, body temperatures of COVID positive patients in a hospital. Number two. So the body temperatures, is it finite or is it infinite? Of course, this is continuous. Thank you, Sir Ricky. The monthly income of employees in a company providing COVID-19 vaccines. Is it discrete or continuous? Well, we would actually think that it's really confusing because, of course, it depends on the hospitals. However, it is clearly defined that monthly income of employees in a company providing COVID-19 vaccine is actually continuous because it varies from person to person, from position to position. Okay. Number four, the number of vaccines donated by China in the Philippines. So this one is can be easily counted. So of course, this is discrete. Okay, thank you so much. So according to measurement, we have two forms of variables as discussed by yesterday's discussant. It's categorical and numerical. So I guess we already know that when I say categorical, they can actually take numerical values, but those numbers don't have mathematical meaning. Okay? While on the other hand, numerical are those data that can be counted. So we have ratio and interval for numerical, and for categorical, we have nominal and ordinal. Okay, now let's go to the actual topic about the differences between or how can we easily understand what statistical tool can be used. So take note of this. The research questions usually prescribe the statistical tools to be used. This is actually found on the aims and objective of your study. Sometimes it's being masked as the problem statement or the thesis statement, but it's more of the specific objectives of the study. Okay? So, for example, the research question, what are the types of stress experienced by the teachers? We can have statistical tools such as statistics, such as frequency. What is the knowledge level of students in mathematics? It could be presented in a form of mean or standard deviation. Is there a significant relationship between the motivation and exam scores of students? So we can actually use Spearman-Rowe or Pearson's R. So whether it's parametric or non-parametric, depending on the assumptions. Now, is there a significant difference between the pretest and the post-test scores of respondents? Well, we can actually utilize the following. All right. So, how about this one? Is there a significant difference among the English grades of respondents grouped according to year level? In this part, since there are a lot of variables involved, such as a year level could be level 1, level 2, level 3, level 4, we can utilize ANOVA or its non-parametric part, which is the Kruskal-Wallis. Now, is there a significant difference among the English grades and math grades of respondents grouped according to year level? So we have two variables here, English and math grades. So therefore, we can use multiple analysis of variance. Now, is there a significant difference among the English grades of respondents grouped according to year level when their entrance scores are considered? So we already have a covariant here. Aside from the independent and the dependent variable, we have another one, which is the covariance. So we can use ANCOVA for this. Another one, is there a significant difference among the English grades and math grades of respondents grouped according to year level when their entrance scores are considered? So take note, we have multiple independent variables, right? Or dependent variables, I mean. And there is a covariant, so therefore this is MANCOVA. Okay. Now statistics, as discussed earlier, can either be descriptives or inferential. So what are the things that we need to consider? Which one to use and which one not to use? Of course, we have the sampling techniques. And of course, I highly emphasized assumptions. And I'm so happy that our previous discussant were able to discuss in detail the assumptions on the following: the independence, distribution, variance, homogeneity, and other that dictates whether you use a parametric or a non-parametric statistics. So let's differentiate parametric versus non-parametric. Parametric tests are actually sometimes, or most of the time, are used for pure experimental research. But of course, in other quantitative research, we can use them as long as the assumptions are met. So why did I focus on pure experimental? The reason is because randomization, control, and everything has been taken into consideration when you're choosing the subject for testing in an experimental research. Well, for non-parametrical tools, if ever your assumptions in a parametric test has been violated, well, you still have a choice to utilize non-parametric test. Okay, so what are the assumptions that we need to meet? First, about the distribution. Second, samples in a form of randomization. The size itself, okay, also the variances must be equal, and the values are both measured in interval or ratio scale, and there shouldn't be outliers. So in general, non-parametric tests are used as substitutes for parametric tests in situations in which one of the following occurs. The first one, if the data don't meet the assumptions needed for a standard parametric test. That's our first consideration. The second one, if the data is consist of nominal or ordinal measurements so that it is impossible to compute the standard descriptive stats such as the mean, right? Because we will be using the median in some instances for those. So the first assumption is about the population to sample. So this is actually sampling. So just take note that if in a given target population, we need to find the best sample that can best represent the entire population. So that is referred to as the sample. So that the entire totality of the target respondents will be the population, while a chunk of those that best represents the target population, we call that as the sample. So it's like this one. It's a systematic process of choosing participants in your study, or respondents perhaps. Now, the first one that I'm going to discuss are actually the non-probability sample designs, which are utilized in qualitative research, like availability sampling, purposive sampling, quota sampling, and respondent-assisted sampling. So all of these are actually utilized in qualitative research. Okay. So, for example, we have convenience sampling. Convenience sampling, whoever is available, you choose them. Voluntary response sampling, it's like whoever wants to volunteer in the research process, you will be chosen as the sample. Now, snowball sampling, it's actually called as such because it's called a referral sampling. Like, for example, I'll choose two respondents. These two respondents must actually tell other people who have the same criteria as with them. They will be the ones to be my respondents afterwards. So it's like a snowball. When you roll a snow and then roll it over and over and over again, it becomes bigger and bigger until you reach the sample size that you would want to have. Now, quota sampling is like I'm going to choose everyone that, well, regardless of the age, race, and whatever, depending on the criteria that I provided, as long as I hit the certain number, that's quota sampling. Okay, what about judgmental or purposive sampling? I impose criteria. Or I impose, like for example, I'm going to specifically interview the municipal mayor of our town. So I'm going to look for him directly. So what about probability sampling? So we have simple random sampling, stratified, systematic, and cluster sampling. So sometimes to determine the size, we usually go for the Sloven's formula. But unfortunately, we have been using Sloven's formula for several decades already. But the exact formula should be attributed to the ones in literature, and that is Yamane. Okay, so that was written in 1967 by Yamane. So they have actually the same formula. Where it's actually N, the small letter N stands for the sample size, the capital N stands for the total population, and the E stands for the allowable margin of error. So let's take, for example, this one. The researcher would like to conduct a study on administrators' performance in state universities and colleges in Region 6, from which the distribution of population of academic administrators was as follows. So, ASU, so on and so forth. So, we have a lot of areas to choose from. So, the using the sample size determination, where we have 70 total participants, well, we can, and the margin of error of 0.05, so we can get a sample size of 60. Okay, to stratify the number of samples per university, we can use this formula. Okay, so like for example, out of 70, we have 6 from ASU, so that is how many percent? That's actually in that way. So we multiply it by the number of, or the proportion of Aklan State University from the total number of the population, and then we multiply it by to get the sample size of 5. Okay. Now, what about the assumptions that we mentioned about? So this is going to be just a sort of review. So there are two assumption tests for distribution. The first one is one sample Kolmogorov-Smirnov's test, or the KS test, as what they say. So if your sample size is less than 50, please use this one. Now this is actually quite good when we're using like just one section, in your classroom. So for sample size less than 50, we use KS test, but for more than that, we use Shapiro-Wilk test. So the test for distribution is kind of like this. I just don't know if you can see my laser pointer. So this is normal distribution. While this one, we have a lot of outliers out there if we turn it into a histogram. Okay, another assumption test is the Levin's test for equality of variance. So if it's more than 0.05 or equal to 0.05, then the variances are equal. Okay, so unlike the other assumptions in hypothesis testing wherein it should be less than that, but this one is more than that or greater than that for it to be good. Okay, we also have Bartlett's test for homogeneity or the homoscedasticity. So if you could notice, the scores or the data are actually aligned in such way, we can say that it's homoscedastic. On the other hand, if it's scattered like this in a scattered graph, like in regression analysis or linear analysis, so we could not actually establish homoscedasticity on it. Okay. What about the box M test for equality of covariance? It means that all your data or covariances are actually inside or just near all the other variances. So if it's like this one, that's not a good covariance. Okay. Now let's go to the different tests when we are testing the different statistical tools as applied to different situations. Now, we're talking about dependent or related samples. It's like one sample has two scores. So, in a given problem statement, it would look like this. Is there a significant difference between the pre-test and post-test scores of respondents? So, the data here comes from the same samples. Like, for example, Section A pre-test and Section A post-test. They are the same people. So we have parametric test for them. If it's less than 30 samples, we use the t-test. It's the paired t-test. If it's more than that, then we can use the z-test. Now, if the assumptions are not met, like for example, it's not normally distributed, or your sampling technique is like purposive, then of course we utilize the Wilcoxon signed ranks test. That's the non-parametric version of the t-test for dependent samples. Now, what about for variables that are coming from independent samples or different samples? Example, The question would be like this in your problem statement. Is there a significant differences between the English grades of respondents when grouped according to sex? So take note that there are two variables here for sex, that is male or female, and the data comes from different samples, male and female. So for that, we can actually use the independent t-test or the z-test. The non-parametric version will be the Mann-Whitney u-test. Okay, how about the differences for more than two variables? Well, it would be easier if it's just two, right? For male or female, or we divide the age between like 15 years old and below and 16 years old and above. There are only two variables there. However, it doesn't happen all the time. So we have a lot of variables. For example, the year level. Okay? And for this one, is there a significant difference among English grades of respondents grouped according to year level when their entrance scores are considered? And is there a significant difference among the English grades and math grades of respondents grouped according to year level when their entrance scores are considered? So if you could have noticed, question number 1, is there a significant difference among English grades of respondents when grouped according to year level? Only one dependent there, which is actually the English grades. Well, we have several levels of variance, like level 1, level 2, level 3, level 4. The second question, English and math grades versus several year levels. So we can consider here that there are two variables to be taken into consideration. The third question, only one variable, but there's a covariant, which is the entrance scores. The fourth question, we have two variables here, the English grades and math grades, and another covariant, which is the entrance scores. So let's take a look. Now, if it is just one independent and one dependent variable, we can utilize ANOVA. That's for question number 1. For question number 2, one independent variable or two or more dependent variable, we can use MANOVA. Now, depending on the result of the box M test, then we can use Pillai's test or Wilks lambda using the MANOVA. Now, for ANCOVA, that's for question number 3 because there's a covariance, which is the entrance scores, one independent and one dependent plus one covariance. Okay? For MANCOVA, one independent, two or more dependent, and one covariance. So also depending on the box M test, we will be utilizing Pillai's test or Wilks lambda. Now, in each of these, we can actually just utilize Kruskal-Wallis as the non-parametrical test for ANOVA. Okay? So what about the post hoc test? This is actually used if you are going to use MANOVA, ANOVA, ANCOVA, and MANCOVA. And that is if the p-value, the probability value is significant. So when you say significant, the p-value is less than or equal to 0.05. If not, then just use Kruskal-Wallis and then utilize the different forms of the Mann-Whitney u-test for each of the variables. Okay, so we have the Fishers, LSD, the Duncans. This is actually used for larger pairs. We have the Tukey. Actually, this one is one of the most popular. And the most conservative is the Schieffes. So I usually utilize Schieffe, Tukey, and Duncans, as well as Fishers in some instances. Okay. Now, as mentioned, if Kruskal-Wallis is significant because you utilize the non-parametrical test, then just use Mann-Whitney again to determine which pairs are significant. For example,
Sa
let's say
araw-araw, tanging ikaw ang palagi kong hinahangad. Laging tanaw sa'yo ang ilaw na nagsisilbi kong liwanag. Lapis ang ngiti kapag ika'y kaharap. Ramdam ko ang pagmamahal, giliw. Namumukot ang ikat, walang katulad. Ikaw lang ang para riyan o aking tahanan. Ta 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 ta. Dito ka lang, dito ka lang, dito ka lang. Ikaw lang at ako ang naaaninag sa gitna ng paraiso nating sinimulan o aking tahanan. Pinapawi